All right, so we're going to continue looking at law of sine, so still in section 4.2. Just a reminder of what the law of sines is if you weren't here yesterday. Sine of alpha over A equals sine beta over B, which equals sine gamma over C. Do we use all three parts at the same time? Excuse me. No, we only use 2 out of 3 of the parts. Depends on what you solve for. You always use the part that represents the complete row, and then you use a part that represents a partial row. So if you do that, you'll always know 3 out of 4 of the numerators and denominators in your proportion. Okay, so there's really nothing new to explain today. We're just going to do an example, go through it, and see what happens. Okay, so here's our problem. We've got 2 sides and an angle. Okay, I'm going to make a quick sketch just so I can kind of classify what type it is, like the ASA or SSA, things like that. So I've got A across from alpha. I've got B across from beta, and C across from gamma. So based on this picture, what kind of triangle is that? Using the S's and A's, yep? Side-side angle. It's side-side angle. You have a side, and you have an angle, but the angle that you know is not the one between the 2 sides. In this problem, the angle between the 2 sides is gamma. If I gave you gamma, you wouldn't be able to solve this. Okay.
Now what made you put them in that order? Or would it really matter what order you put them in?
It doesn't matter. You can sketch the triangle basically however you want, as long as wherever you put A, you put it across from alpha. Wherever you put B, you put it across from beta. That's like beta. And wherever you put C, you put it across from gamma.
Okay.
Okay? And that's still side-side angle. Okay? You just have to maintain that relationship, what's across from what. Okay, so we have an empty row. Nothing we can do with it. Completely ignore it for now. Only thing I can try to solve for right away is beta. So Lexi, could you set up my proportion to help me find beta? We got sine 35 over 6.
And sine beta over 8.
Sine beta over 8. So the goal is to get the sine beta by itself first. I can do that, Brady, by multiplying both sides by, just multiply both sides by 8. There's really no need to even cross multiply. So again, 8 sine 35 over 6. Equals sine beta, but we still want to get rid of sine. So Abby, how do I get rid of sine?
You do the sine waving model.
Yep. Anyone? Do you remember the name of that?
Yeah.
Inverse sine. So we're going to take the inverse sine of what's on the right. Take the inverse sine of what's on the left. And now we're going to type it in and see what we get. So we've got second inverse sine, 8 sine 35. Make sure you close that parenthesis. Divide by 6. And now I got negative 0.607. Clearly I shouldn't be getting a negative angle. So what did I do wrong? If that happens to you on the test, you got to figure it out yourself. What's wrong here? Yep.
I did the same thing and I got 49.86.
That's what you should get.
Oh.
How come I didn't? Yeah.
Are you in green?
I'm in radians. I'm in the wrong mode. Okay. So I got to go back to degrees. My calculator, I don't need to retype it. I can just press second enter. It'll bring it right back. And now I get what I should get. It's 49.886. Okay, what would have been even worse is if I got an answer that was positive. Say I got 10.5. I may have thought 10.5 is right. Oh, it's a positive number. Seems good. I wouldn't have even realized I was in the wrong mode. Luckily, I got a negative answer, so that kind of made me right away be like, something's not right. All right, so 49.886. What do I do with the 49.886 to get the second answer? Yep.
Take it away from 180.
Yep, subtract it from 180. So if someone asks the question, is there a second answer? There's always a second answer. Does it work? That's a different question. Okay, so we're going to find the second answer. I'm just going to do 180 minus what I just had on the screen. And I get 130.116. So, Caitlin, what was I given to start with for an angle?
35.
35? Can you fit a 35 and 130 in the same triangle?
Yes.
Yes. It only adds up to 165. So this time the second answer does work. Okay, so I'm going to write it down. I'm going to call the first one beta 1. Call the second one beta 2. And what was it again? 130.116. Okay, so first of all, questions on how I got the 49, the 130, and why it works this time. Yep.
Wait, you got the 130 from minusing the 49 from 180, or?
Yes.
Okay.
All right, so now what we want to do is set this up so everything has two answers. We're going to have two answers for gamma, and we're going to have two answers for C. The information that was given, that is what it is. You don't have to find two answers for the stuff that was given. Just the stuff you have to find. Okay, so I'm looking for six things in this problem. Just to kind of make it clear what's what here, I'm going to put boxes in color around the information in one triangle and then the information in the second triangle. So in the red triangle, we have alpha, beta 1, and gamma 1. Those are the three angles in the red triangle. In the green triangle, we have alpha, beta 2, and gamma 2. So what I just put green boxes around, that's the second triangle. And if you're like, well, you put a red and a green box around alpha, yep, it's in both. Okay, the red and the green triangles share that angle. Okay. And then as far as the sides, we kind of want to lay those out. A is in the red triangle, B is in the red triangle, and C1 is the red triangle.
So we can have more than one answer only if it's side-side angle, or?
Yes,
Okay.
that's the only time it can ever happen.
Okay.
Yep. So those are the three sides in the red. These are the three sides in the green. A is shared, B is shared, and C2. So now there should be 6 green boxes, 6 red boxes, and those are the things in the red, 3 sides, 3 angles, and then the things in the green, 3 sides, 3 angles. Okay. Okay, so now let's find gamma 1. To find gamma 1, you're going to take alpha and beta 1, because they're in the same triangle, add them up, and subtract from 180. So we got... So let's add them up. Let's see, we got 35 plus 49.886. That's what those take up. Subtract it from 180, that's what's left for gamma 1. Okay, should have got 95.114. Any questions on how I got that? Now at this point, if you want, you could find C1. But I kind of like to just finish the angles off, so I'm going to find gamma 2 first. Jordan, what are the two angles I'm going to add up to get gamma 2?
Beta 2 and alpha.
Yep, so 130.116 plus alpha gives me 165.116. Subtract from 180. And there's gamma 2, 14.884. Okay, any questions on how I got gamma 2?
Wait, which ones do you use that up?
To get gamma 2,
Yeah.
I did beta 2 and alpha. So the 3 green boxes should all add up to 180. The 3 red boxes should all add up to 180. 2 separate problems. Okay. All right, now to find C1, you use gamma 1. To find C2, you use gamma 2. But I need another row besides that. I need a row that has everything in it. And now I have to decide which row I should pick.
On the test, you wanted to find first and a second.
If the problem has 2 answers, oh yeah, yep. If the problem has 2 answers and you only give me one of them, you lose half. Yeah, you have to find both. Yeah.
Now, how lenient did you say you'd be with like getting the exact? Because I typed in the exact same thing as you did. Instead of .884, I got .886.
That's probably, you know what, maybe I even typed something, let me double check. 130.116 plus 35. I might have even just copied it wrong. Plus subtract from 180. Yeah, I got 884, I don't know.
I also got 886.
Okay, maybe I typed it wrong again. Did anybody see me type it wrong?
I think those calculators
I
are
get
just
88
the
too.
built
I got
in.
88.
It's not a huge deal. I mean, we should all get the same answer because it's math. It shouldn't change. But 130.116 plus 35 gives me that. And I'm just making it negative and adding it to 180. So I'm not sure.
I think because the beta 1 was supposed to be 49.88. Oh wait. Or no, the beta 2 I got 130.114.
Oh, you got 114? So that might be one that I copied wrong. That's not a huge deal. If you got if you got 15 point something here, that's kind of far off. If you get 14.89, 14.87, 14.90, those would all be okay.
Would you mark that wrong on the test?
No, those would all be okay. But if you get like 15.2, then I'm going to be like, it's getting kind of far off from where it should be. So that's probably me. I just probably copied something. But does anyone want me to go back and double check beta 2? Okay, all right. So let's find C1 and C2. All right, let's do C1 first. So besides gamma 1 and C1, I have to pick another row that has everything in it. So I have 2 choices. A and alpha, that's a complete row, in the red triangle. And B and beta 1 is a complete row in the red triangle. So which row should I pick? Row A or row B?
A.
Yeah, we should stick with A because it was given. There's no decimals. It's easier to work with. Okay, so let's find C1. So we're going to have sine 35 over 6 equals sine 95.114 over C1. And now from here, we just cross multiply. Technically, I shouldn't put an equal sign because I've already rounded something off. So this answer is, it's even more rounded off. But since we went to 3 decimal places, we should all be at least accurate to 2. Right? If you're a little off in the 3rd one, that's okay. Okay, so we get 6 sine 95 over sine 35. Okay, let's plug that in, I'll see what I get, and then I'll tell you kind of like what I would accept on the test. All right, so we get 6 sine 95.114 divided by sine 35. Okay, so you should get about 10.419. If you had 10.42, 10.44, that's fine. If you had like 10.7, that's too far off. Okay, if you had like 10.1, that's too far off. Okay, anything around 10.41, 10.42, 10.4, that would be fine. Okay, so any questions on that? Okay, so that's C1. Okay, now the last thing is to find C2. Again, besides this row, we have 2 complete rows in green. A and alpha, or B and beta 2. That's a complete row. Which row should I use here? Yeah. Yep. I'd use the first row again. It's in both triangles. There's no decimals. It was given. You know it's right. If you use the second row, you're probably still going to be okay, but you're just using more stuff you calculated. So if we can avoid it, that's what we do. Okay, so we'll start it the same way. Sine 35 over 6. Equals sine 14.884 over C2. Okay, now I'll just cross multiply and type it in. So 6 sine 14.884 over sine 35. Okay, and did anyone already type that in and have what it comes out to?
Yeah, 2.687.
2.687. Yeah, I think I remember in the past getting 2.686. So it's definitely close enough. So if you had 2.69, 2.70, 2.71, that's fine. 2.9, yeah, no, that's too far off. You did way too much rounding or you just did something wrong. Okay, so basically, like within 6 or 7 hundredths. Okay, so up to a tenth. Sometimes it depends, but you know we should all be the same to the tenth, really. Okay, and pretty close on the hundredth, within a few hundredths. Okay. Okay, and that's as bad as a law of sine problem can get. Okay, that's the 2 solution. Doesn't really require anything new. It just requires doing everything twice. So it's double.
Wait, define C. Did you use gamma 1 or gamma 2?
Which C?
The second C.
C2, gamma 2. Yep. So to find C2, you use gamma 2, which is the 14.884. Any other questions on that? Okay, so what I'm going to do is I'm going to try to sketch out something that's a 2 solution. Okay, just to show you how that would look. Okay, I'm not really going to sketch anything specific. It's going to be kind of hard for you to do this in your notes, so really just watching it is probably the best idea. Just all right, so what I'm going to do is try to show you how to sketch an example of a 2 solution case using 2 sides that are the same and an angle that's the same, but I'm going to get 2 totally different pictures. Okay. That's what we just did in the last problem. Okay, so first thing I'm going to do is just make a copy of that side, put it right there. Okay. Does everyone agree that those two sides are the same length? They just are copied. I'm going to take this side. And there's other ways to do what I'm doing. This is just one way. I'm going to take that, make a copy of it, and I'm going to flip it. Just like that. Okay. Does everyone agree that that and that are the same? It's just a mirror image, so it's still, if you measure it, it's the same length. Okay, and for the third side, just going to connect the bottom like that. And now I'm going to group all that together. And if you're like, well, wait a minute, where's the angle that's the same? Well, if you group all that together, the angle that's the same is the one in the lower left. They're exactly the same. So this angle matches that angle. Side, side, angle. So basically, if I gave you like pieces or sticks of things you could put together, and I gave people this kind of situation, and you started putting your sticks together, and I said, all right, you have to have these sides the same and this angle the same. Some of you might build the triangle on the bottom. Some of you might stack your sticks together and make the one on the top. But everybody would get one of these two. If I gave you this first length predetermined, the second length predetermined, and I said you all have to have that angle in that spot. You can build two different triangles. Okay. So that's visually an example of the two solution. Okay. Any questions on that? All right. So let's look at this one. So this is an example of again, you have a row that's complete, so I know it's dealing with law of signs. I have a row that's empty, so I got to ignore it. There's nothing I can get out of that row right now. Okay, so first thing I've got to find is alpha. Okay, so let's set it up and see what happens. So remember, we're looking for one of three things. One solution, like we did yesterday, a two-solution problem, like we just did, or a no solution. One of those three things. Okay, Ethan, can you set up my proportion for me to find alpha?
Sin 2 over, wait.
So remember, when you do the sine, the thing that goes inside the sine function is always an angle.
Alright, and sine alpha over 2.
Yes, sine alpha over 2.
Sine 50
Mhm.
over 1.
Over 1. There you go. Okay, so now we want to cross multiply, but really we don't even need to do that because sine of 50 over 1 is just divided by 1, so it's really just sine 50. So just double each side. So we get sine alpha equals 2 sine 50. And now I want to get alpha by itself, so to get rid of sine, inverse sine. So it's the inverse sine 2 sine 50. Now, before I type that in, I'm just going to type in 2 sine 50. I'm not going to do the inverse sine yet, because I want you to see something. When we graphed the sine function last week, what was the highest and the lowest that it ever went, if you didn't do anything to it? Like the original graph. Yep? 1 and the lowest?
-1.
-1. It always went between 1 and -1. Well, look at the value of 2 sine 50. It's 1.5. So when you try to take the inverse sine of 2 sine 50, you can't. Because you're trying to take the inverse sine of a number that's not between -1 and 1. Well, why does that really matter? Because if I graph sine of x, and I graph, let me just speed it up a little bit. And I graph whatever the number we just had was. What was it? 1 point. Just go back. 1.53? Yeah. So if I graph that number, and I graph the sine function, and then I ask you, where do those graphs cross? Where do they cross? They don't. So that's why, visually, that's the reason why you got an error. You just tried to find where two things cross that don't. Okay? So my calculator, I think it said domain error. Okay, what yours does might be different. Same thing. But the point is there's no solution for alpha. So no solution. Now what we would normally do is we would add that up to 50 to get beta. But since I don't have an answer for alpha, I have nothing to add to gamma. So I can't find beta. And if I can't get beta, then I can't get the side across from it either. So that's also no solution. Okay, so if one thing is no solution, it's all no solution. And you're done. There's nothing else to do.
Will you ever get one that like you can solve part way in, like just say you could find alpha and then you got no solution afterwards?
Nope. Nope. So if you should know right away that it's no solution. Okay, and I'm going to try to draw this triangle to scale. How come what? That was given to us. A, C, and gamma, everything without a box around it, they told us that information. All right, so what I'm going to do is I'm going to try to sketch that triangle to scale and see what happens. So I already used a protractor earlier, and that's exactly a 50-degree angle. Okay, there's a protractor thing on here under measurement. Doesn't seem to like me right now, so I can't show you, but that's why I did it earlier. Now, I need a side that's 1 unit long and 2 units long. Okay, so let me sketch that. So let's call this side 1 unit long. And to get a side 2 units long, just put 2 of them together. Okay, so there you go. There's a side 2 units long. Any question on that? So now, let's look at where A is supposed to be. A is 2 units long. So what I need to do is set A at a 50-degree angle. Okay, and that's where I can use the angle I already drew from the protractor. So we just need to turn it. And that's close enough. I can't change that. For this entire problem, I have to keep that at a 50-degree angle. All right. Side B is the one on the bottom. B can be as long or as short as you want. Okay, they didn't tell me anything about B. So let's just put B like that. C is the side that's 1 unit long, and that comes off from the top side. So C is right there. Okay, I can rotate it however I want. Because they did not tell me what the angle at the top has to be. Pick anything you want. And they didn't tell me how long the bottom side has to be. But no matter how long or short I make the bottom, or how I turn that one at the top, will they ever meet? No. I mean, you can try, you can shorten it, you can try to turn it a little bit, but no matter what you do, they're never going to meet. Okay? That's why this is a no solution. Any questions on that? All right, let's finish up with the 2 word problems. So, if you were given a word problem, this would all be written down for you. It's kind of a lot to write. But the idea of this problem is that somebody's trying to measure the elevation of an object in the distance, and it's not easy to measure it directly. So maybe it's a mountain, a tree, something you just can't take a tape measure and easily measure. So you can do this as long as you measure, as long as you take 2 observations. Okay, you basically have to stand in one spot, measure something, back up, measure it again, and then from there you can use trig to find out how tall the object is in front of you. Okay? And what's nice about this method is you don't have to know how far away the object is. Okay? For some methods you'd have to go right up to your object and then measure the distance away from it. You don't have to do that. Maybe your object is on the other side of a canyon, so it's not easy to go right up to it. Okay? So what we're going to do is take 2 measurements, okay, or they're called sightings of the peak. And what we're going to measure about the peak is the angle of elevation. So pretend like we're standing, we have a tripod set up. Sometimes you see surveyors do this, like in property or on the streets, because they're measuring angles and elevations. And what we're going to do is we're going to shoot an angle using a laser to the top of the mountain. So we'll look through like a little scope, we'll turn the laser on, and it's going to go right to the top of the mountain. We're going to do this twice from 900 meters apart. This 900 meters can be anything, as long as it's a distance that you know. So if you're in a car, all you have to do is turn on the trip meter, back up 900 meters or whatever distance, as long as you know the distance, and you can do it. So the first time we shoot a laser to the top of the mountain, we get an angle of 47 degrees. Now, what do you think is going to happen to the angle as you back away from the mountain? Like if you keep the laser pointed at exactly the same spot and you back up, what's going to happen to the angle? Yep.
It's going to shrink.
Yeah, it's going to go down. It's kind of like if I keep my eyes fixed at a spot, that's above me. Well, if I'm right under the object or close to it, I'm looking almost straight up. As I back away from the object, I don't have to look up as steep, like a movie screen kind of thing. So the first time we get the angle, it's 47. The second time we get the angle, it's 35. The device that you would use to do this is called a transit. We're going to assume the transit is level with the ground. That's really not true. The transit would be on a tripod. So what we would actually have to do is then add in the height of the tripod after. But I'm not really worried about that. So we'll just pretend like the transit is on the ground. Okay. So the question is, find the height of the mountain. Find the height of the mountain. Okay, so there's a lot of information there. What do you think it would be good to do with all that information? Yeah?
Draw it out.
Yeah, word problem, definitely draw it out. Hopefully we're going to see some triangles in there and kind of go from there. Okay, so first thing I'm going to do is draw ground. It's as straight as I can draw without being able to draw a line. Okay, so there's the ground. The mountain. There's the mountain. It's a little steep on the back, so be careful. We're going to take 2 sightings of it. Okay, we'll do one from here, one from there. How far apart are the 2 sightings? Yeah?
We don't know.
Yes, that's one thing we have to know to be able to do this.
900 meters.
They're 900 meters apart. So distance of 900 meters apart. So that's 900. Okay, the first time we measure the angle, I'm going to just put the angle going right to the peak. What's our first angle of elevation? The first time that the surveyor measures the angle. Yep. 47. All right. And then we do it a second time. It's as good as I can do by hand. And then the second time we get an angle of 35. Okay. So the goal, using that information, is basically to find this, which is the height of the mountain. Okay, so let's, just for a second, let's trace this out, this triangle right here. And just to move it away from the picture so we can kind of look at it a little clearer. I want to find the height. Now, I can't directly work with the height. So what am I missing in that triangle that's in red to be able to find the height? I don't have any what? I don't have any sides. So unfortunately, I can't do anything with that red triangle right now. Okay, I have to find a side first. So we'll come back to that triangle, but instead, let's focus on this triangle, which shares a side with the red one. And that's going to be the key. Okay? They share a side. So if we can find the side they share, then we'll know a side in the red triangle, then we can find the height. Okay, so let's label some stuff here. We know this side is 900. We know this is 35. Well, what else can I label? It's not directly given to me, but I have information to find it.
The large angle.
Yeah, how would I get that?
Go ahead, subtracting 47 from 180.
Yep. Subtract 47 from 180. Now I know this angle is 133. And now I can find something else. What could I find now? Yeah?
The other angle.
I can find the other angle, which is important because if we're going to use law of sines, you have to know a side and an angle across from it. So now I can get that.
How did you get 133?
So we subtracted 47 from 180 because together they make a straight angle. This part and that part. All right, so now let's add these up. 35 plus 133, that gives me 168, which gives me 12 for this angle at the top. Okay, and let's just call this other side A, which is also the hypotenuse of that red triangle. Okay, now I'm going to find A. I don't care about anything else, just A. So we're going to do sine of an angle divided by the side across from it. So sine of an angle divided by what's across. And can anyone set up what would go on the other side?
Sine 35 over A.
Yeah, exactly. Sine 35 over A. Now, A is not the height. Okay, keep that in mind. A is one step away from the height. It's what we need to do next. Okay, let's get A. So it's 900 sine 35 divided by sine 12. Okay, kind of big numbers, but I'm just going to plug it into the calculator, so that doesn't really matter. Right, so 900 sine 35 divided by sine 12. Okay, so we get 2,482.86. 2482, I'm sorry, 88.88. Okay, any questions on how we got A? Okay, so I'm going to fill that in up on the red triangle. 2482.88. You just cross it out. Now I have a side in the red triangle, and the red triangle is not just any kind of triangle. What kind of triangle is the red one? It's a right triangle. So now Pythagorean theorem, SOHCAHTOA, whatever stuff you want to use with that, you can. Or you can use law of sines, but you don't need to. So from the perspective of 47, what's the name of side H? Opposite, adjacent, or hypotenuse?
Opposite.
Opposite. And what about 2,482.88? Hypotenuse. What trig function uses opposite and hypotenuse? Sine. So this is what we did 2 weeks ago. So the sine of our angle equals opposite over hypotenuse. And what operation would we use to move that 2,000 to the other side? Multiplication. Right, so we have this 2,482.88 times sine 47. And that's the height of the mountain. 1,815, we'll just say 0.9 meters. So 1815.9. And in terms of mountains, whether or not that's tall for this area, that's pretty tall. In terms of feet, this isn't exact, but if you take meters and triple it, it's not yards. Meters are a little bigger. So this mountain is probably around 5,700 feet, which would be pretty tall for this area. Mount Wachusett, about 2,000. Monadnock's 3,165. Mount Washington, which is the tallest one in the Northeast, is about a little over 6,000. I think 6,200 something. So this would be pretty big for this area, but obviously out like in Colorado, they have, or even California, they have mountains in the 14,000 foot range. In Alaska, even taller. So, you don't have to know that. Okay. So any question on how we got the height? So a little tricky because you can't find the height right away. You have to find something else first, and then you can find the height. All right. So homework tonight, 267, same section as last night. 29 to 35 odd, 39 and 43. Okay, so tomorrow we should be able to finish up everything for the week. Thursday review, Friday test, and the test will be on term 4.